Welcome to RadioBro Corporation. This is a summary of MiniSatCom, a communications module for small satellites. MiniSatCom is a communications module designed for small satellites, likely less than 10 kilograms, such as CubeSats or Pocket Cubes. The modules are made in the United States, but they're sold worldwide based on export restrictions. The modules provide a high-performance RF system. They are produced in a production environment providing high reliability and an affordable price. The system is designed to minimize the learning curve to operate the radio. Developers' tools are available to assist you in the development process. The module has 3 digital interfaces. The digital interfaces are the interface to the embedded system within the spacecraft, and it allows this module to fit almost anyone's architecture within their spacecraft bus. The module has internal power conditioning with high efficiency DC to DC converters for all internal operations. The module features output pins which allow you to have effectively an on-orbit reset button. Using modern manufacturing techniques, the system has a mass of less than 10 grams. It measures 44 by 30 millimeters and is 5 millimeters thick. MiniSatCom uses commercial electronics but is manufactured at aerospace quality. MiniSatCom has an aluminum enclosure which the electronics are potted inside of. This is designed for a rugged environment and is easily mounted inside of your small satellite. We offer 2 different data bands so you can operate in full duplex mode, half duplex each. The radio has an MMCX RF connector and an electrical connector that is accessible from either side. The module has 3 threaded holes, one on each corner, to provide for mounting. MiniSatCom comfortably fits inside of a CubeSat. In fact, 2 modules will allow for full duplex operations and fit comfortably on a single layer within a CubeSat. As you can see, we have one in the 420 MHz band and one in the 902 MHz band. Separately, the new Pocket Cube class small spacecraft is currently in development worldwide. MiniSatCom comfortably fits inside of the Pocket Cube form factor, enabling the smallest missions to be successful. MiniSatCom has an electrical, mechanical, and an RF interface. The mechanical interface is based on a rectangular aluminum box. This box has 3 screw-down locations, seen in the top right figure. These holes are threaded 256 ANSI threads, and those threads are physically located in the back cover. This is only the lid to the radio. Other lids are available separately, featuring clearance holes or metric holes as needed for your mission. The heat is most efficiently synced from the spacecraft radio through the component case. The electronics are potted into the aluminum, and this allows heat to transfer efficiently to get to the outside of the aluminum on the component case. So, as you integrate this against the circuit board or a piece of your spacecraft chassis, this is the most efficient side to place it on. Electrically, MiniSatCom has a 20-pin header for the digital and power interface. This header is accessible from the top or the bottom, but most likely you will interface through the bottom, of which the shroud of your pins falls into a recessed pocket of the component case. Of the 20 pins, the power input can be unregulated 3.0 to 5.5 volt input, and will require approximately 2 watts of electrical power while transmitting at peak RF power. The digital voltage interface is set separately and can be set anywhere from 1.8 to 5.5 volts depending on your system, and that will be used for all TTL logic pins. The RF interface to MiniSatCom is a 50 ohm MMCX jack. A mating MMCX plug should be used to attach your antenna. This can be mounted directly to a PCB or to the end of a coaxial cable. If the MMCX cable is not engaged, the RF is passed to an internal RF load, which should allow the developer to feel comfortable with software development even without an antenna installed. This is to protect the radio and prevent any concern of internal damage due to inadvertent transmission without the antenna connected. MiniSatCom has a complementing developer's board. This is to enable your development team to begin using the radio as soon as you open the box and prevent any delay in your schedule. The developer's board enables simple use of all features of MiniSatCom. The board has an onboard USB to serial converter and USB power to allow you to operate the radio with no additional systems. The header row at the bottom of the board allows you to connect any wire from the radio to a breadboard setup to allow prototyping and testing of the radio. A logic analyzer and an oscilloscope interface are included for all pins on the radio, so you can monitor the operation of the system. Here you can see the developer's board. In the center is where the radio will be located, and the thermal pad ensures a good thermal connection to the board itself. The header at the bottom and the dip switches enable your connection from your prototype setup to the radio itself. You see on the right side that there are oscilloscope hookup locations where each pin and a ground is there for you to probe. On the left side there's a logic analyzer interface. The serial port can be diverted to the FTDI USB to serial converter to allow you to command and control the radio via USB. Power can either be from the external user header or from the USB power input at the top of the board. By simply flipping the switch, you get access to this. The logic voltage is set by either the external user header or by selecting the power source. It should be USB or external header power. The FTDI module operates at a serial TTL voltage of 5 volts, so it is compatible with the USB power. The RF enable has a switch so you can enable transmit on the radio during development. The radio fits comfortably on the board. The supplied antenna operates at both 420 and 902 MHz. Simply install the antenna. Install the radio with the recessed pocket face down so the pocket fits around the shroud of the pins. The MMCX can then be inserted on the left side of the radio. From the bottom of the board, we will now insert 3 screws. Notice the heatsink on the bottom of this board. This is only necessary for continuous operations of the radio. Now the developer is ready to operate the developer's board. Ensure all switches are in the proper locations for your setup. A current shunt on the right side of the board allows you to measure the current draw of the power supply if desired. By using the developer's board, it allows your software and testing teams to start working much sooner in your development process. By using this developer's board, you don't have to wait for your spacecraft prototype to be ready to begin operating your radio. MiniSatCom has a wide variety of modulation, data rate, and frequency adjustability. The easiest communication method to a MiniSatCom module is by another MiniSatCom module. This allows for a minimal learning curve for the encryption and data encoding methods used within MiniSatCom. A low noise amplifier within MiniSatCom enables higher sensitivity for ground station operations or in orbit. Configured properly, MiniSatCom can communicate easily to G3 RUH ground stations worldwide. RadioBro is happy to work with customers to identify other popular ground station options for your mission. For more information about MiniSatCom, please visit www.radiobro.com/developers/MSC. Here you should find how-to videos, example code, example configuration files, example schematics, and mechanical drawings to assist your design process. Please contact RadioBro if you have any questions about MiniSatCom or any other product RadioBro offers.